Know your network, utilize RIS and RIP at last to your advantage.
Am I on the first slide? Let me just go to my first slide. Sorry, let me just try this clicker. The clicker doesn't seem to work. Oh, yeah. Okay, I need to. Yes. Let's see. Does it work? Yeah, it works now. So good. Well, good afternoon, everyone. Thank you for being here after lunch. I hope we are still awake. So my name is Lia Hestina. I work for the RIP NCC. RIP NCC is one of the 5 internet registry, and our region is Europe, Middle East, and a bit of Central Asia. At the RIP NCC, our activities, it's kind of similar to what APNIC is doing. So we are the internet registry. We deliver training courses, webinars, and next to that, we also develop internet measurement tools and other tools in order to help and to support network operators. So in today's presentation, I'm going to talk to you about 2 of the tools that we have, that is RIS and RIP Atlas, and how you can utilize it as a network operator in your day-to-day job. And we're going to cover RIS, which is Routing Information Service, RIP Atlas, which is the Internet Measurement Platform, and then we will also cover some demo about the new UI. We have a new UI with RIP Atlas. And then the last but not least, I'm going to show a demo that was done by Swapnil in how to install software probes. Okay, let me start with this. We all know, right, that the importance of routing security. Yesterday, we have a talk from Tashi Punso. He was talking about routing security and the importance of it. I'm sure many of you know about this incident many years ago when YouTube prefix was hijacked. And after this, we understand the importance of routing security. So I'm not going to talk about this specific incident. I'm going to ask you to imagine if this situation happens to you. Now with our PKI and ROA, it helps a lot already in securing your routing. But what if this thing happens to you? What would you do? What kind of impact it will have on your business, as a network operators? Of course, you will have angry customers, right? If this thing happened to you, because nobody of your customer can connect to you or reach out to you. There will be panic. You know, a few months ago, .bd was not reachable, something like that. No transaction, there can be a lawsuit possible. So all these possible impacts are very important. And they're all bad for your brand. I think we can agree with that. So what do you do? So in this context, I'm going to talk to you about the role of RIS, which is Routing Information Service, as a tool to detect any unauthorized or incorrect announcement. So what is RIS? RIS is a routing data collection platform. We've been collecting BGP data since more than 2 decades ago, since 1999 in fact. And it's not like the static routing registry or the database. RIS is collecting BGP data, so real life information. And what kind of information that RIS is showing? So it's showing information such as what is currently being announced and where, and what is which prefix is currently seen and not seen. And we have a wonderful community of RIS with more than 1,300 global peers, and we have 23 collectors around the world. So what is the tools? How can RIS, how can network operator use RIS? We have tools that we developed, which is called RIS Live. So with RIS Live, it's giving updates of, live updates of BGP data. And then we have APNIC NetOx. If you know APNIC NetOx, it's also using, some of the cards is also using RIS Live data. And the cool thing about RIS is that there are tools that were developed by the community members, such as what they call BGP Alerter. It allows you to be alerted for all the announcement which is unexpected. So if you monitor your prefix, for example, using BGP Alerter, if it's announced by someone, you will be alerted. There's also packet fees. So this is what RIS can do, right? It can help you proactively manage your internet traffic. This is the view of the visualization of our RIS Live data. So on the left-hand side, you have the parameters that you can adjust it to your to what you need. So in this case, I use one prefix, one block of prefix that I know it's in Thailand. And then on the right-hand side, you will see the result. So once you put this block, and then you wait, and then there's a suspense, of course. So it's kind of exciting when I was using this RIS Live. And then you can see here that there was an update from one of our RRC 24. This is an RRC in Montevideo, and it's announcing this IP block. So these are the things that you can do with RIS. This is the link to RIS Live. You can try it yourself. Another visualization that one of our colleagues is creating in order to show what kind of data RIS is showing. This is AS hegemony that is in Thailand. So each node represents one AS. And as we can see, there are 2 large ASN. One is registered within the country, and the other one is not registered within the country. So you can see here the importance of these 2 large ASN, because there are so many other networks that are connected to them. So we want to reduce redundancy. As I mentioned earlier, we have more than 1,300 peers around the world. So we don't want to repeat the same information, collecting the same information, right? So one of our colleagues, Emil Aben, he did a study in order to be able to determine which network do we have to peer with in order to improve our RIS data. So this is based on the hops within Thailand. These networks, if they peer with RIS, it will help improving the hops and reducing the hops and making it closer to our infrastructure. So if you are one of these ASN, come peer with us. All right, I already talked about RIS, which act like data control, and now I'm going to talk about RIPE Atlas and how you can monitor your network and keep your customer latency low. So before I start with this, I would like to ask the room, who has used RIPE Atlas? Please raise your hand. Only three, 4 people. Who heard RIPE Atlas for the first time? Only 2. So some of you heard about RIPE Atlas already, but you don't use it yet. All right, that's good. You are my market then. So RIPE Atlas is an internet measurement platform, an active internet measurement platform that consists of thousands of vantage points. At the moment, actually, more than 12,000 vantage points. Tiny devices. It could also be in a software connected 24/7 in many networks globally. So the idea of having this platform is giving you access to view your internet reachability. So having all these nodes connected everywhere in the world to measure how is your network, how is your critical infrastructure from all the nodes that we have around the world. How do they experience reaching to your network? And these probes are hosted by volunteers, and we use credit system because we want to make it fair for everyone, and also to prevent any overload to the system. And what I mean with the data publicly available, it's the measurement result that we collected from from everyone who used RIPE Atlas. We made it publicly available for your own use so that you can reuse the result and you don't have to use your credits later. So this is where are all the probes located. As we can see, the density is within Europe and also in North America. And that's why I'm here, to talk to the community, to talk to our peers, and see how we can deploy more RIPE Atlas. Because right now, we only have 346 in Southeast Asia, and that's not much. If you look at the geographical location, the topological situation in every country within Southeast Asia, there's so many ASN. We would like to cover at least the top 10 eyeball networks and 1 in every big city. That's the list, and so that it will be a bit more representative and it will be useful for your use, right? So the more diverse the network, the better, the more representative the data that you will get from RIPE Atlas. That's why it's important to have the diversity and more deployment in Southeast Asia. So with RIPE Atlas, you can access using the graphic user interface, API, and also CLI tool. So if you would like to integrate RIPE Atlas measurement into your own measurement tool, for example, you can use the API calls. And what type of measurements can you use with RIPE Atlas? There's ping, traceroute, DNS, SSL/TLS, NTP, and this is the interesting part. Some people would like to host what we call RIPE Atlas anchors. It's a superpower probe because it's attracting measurement from 500 probes in the surrounding, and you can use RIPE Atlas anchor as target for your HTTP measurement. What about security and privacy? We find security and privacy very important with the probes, with the hardware probes. Later I will talk about the software probes. It's from trusted material. It has regular server address, it has keys, and there's no open ports. And the probe is the one that initiate the connection, and you can put it behind a gateway, behind a NAT. And what about the measurement? So it's an active measurement, so it will only initiate a measurement initiated by the probes through SSH connection. from probe to the server. And the code that from the measurement will be made publicly available. All right, now you have the basic information about what RIP Atlas is, where are the probes, and how you can use it, right? Let me give you a short example, a use case this is an example that I always use. This is a real example that happens actually maybe 5 years ago. It's kind of old, but still valid. So this is a guy who works for a gaming company, and so they run their own LAN, and of course with gaming company you have users around the world, right? And then so some gamers, some end user, they were complaining to the guy because they were experiencing high latency when they try to reach certain server, and they are from different networks. So this guy knows RIP Atlas, so he used RIP Atlas already, and he knows that RIP Atlas has vantage point in many end user locations. So he ran a measurement using the graphic user interface. It's quite easy and straightforward. You don't need to have a technical background to be able to use the graphic user interface. So he ran this measurement from various ASN where the gamers were coming from, right? And then he spot the first issue, which is the latency. The latency is very high. So this is more than 200 milliseconds. So if you're a gamer, you can imagine how does it feel, you know, gaming, trying to shoot a bottle or something with that latency. With RIP Atlas, not only you see the latency, you can also see the path it's taking from one point to the end point. And then with this information, you can see where is the problem, which network should you contact. And with this information, you can talk to your peers, to your ISP or upstream provider, or whoever it is that can help you improve the RTT. So he did all of that, and then he ran exactly the same measurement using the same probes, and the result is much better. It's like around or below 5 milliseconds. So you see the significant difference when you are able to spot where the issue is. Of course, now it's hooray moment, because the performance is improved and the shorter path is selected, the latency is better, so now you have more reliable and you have more control and flexibility. What I mean by that is when you use RIP Atlas platform, you can run as many measurements, as many tests as you want or as you need, not as you want just for fun, right? Without having the headache of, you know, a big investment or breaking your bank. And we heard many times that the service desk, so the first point of contact, they love RIP Atlas graphic user interface because it's easy to use. When someone calls and claim that the latency is high from one point to the other, you can just immediately run the test using the graphic user interface of RIP Atlas. So within the Asia Pacific, we've worked closely with APNIC, NSRC, ISOC, and many people that we call RIP Atlas ambassadors. They help us in distributing probes, educating people, and raising awareness about RIP Atlas within Asia Pacific region and also globally, actually. So we would like to thank them. But RIP Atlas community consists of many more than that. You have the probe hosts, you have sponsors who support us financially, you have researchers who use RIP Atlas data and RIS to do their research. We have developers and GitHub contributors, so many people. We would like to thank them. Without them, we will not be where we are right now. All right. And now let's have a look at what we see from RIP Atlas point of view in Thailand and also Southeast Asia. So I mentioned already that we only have less than 350 probes within Southeast Asia. That's not enough. In Thailand, we have only 27. So if you talk to me yesterday and you get probes from me, make sure that the probes are connected. And let's bring Thailand in the map with a very good coverage of RIS Atlas. Yes? So these are the eyeball networks with ASN where we want to have probes. If you are the ASN holder of these networks and interested in hosting a probe, please come and talk to me later or today. We have some probes. We have some probe left. You can check it. This is a prototype tool that you can see and check yourself. If you're not from Thailand, you can check what's happening in your country, which network we need to cover, etc. So in the beginning of this presentation, I mentioned that RIS develop tools in order to help and to support network operators. So anchors, I already mentioned, this is similar to probes. And we have K-routes. This is the deployment that we have in Southeast Asia. And the last one is auth-DNS. This is the servers that we have that we would like to expand. So it would be ideal if we could put one auth-DNS server in one in every country, preferably in an interconnected location like an IX or large ISP. So please talk to me if you're interested in hosting this node later. In Indonesia, we have anchors, we have K-route, we have auth-DNS, so we have everything there, which is good. And now, with RIS Atlas, you can see whether a path is going outside the country and whether they are going through an IX. So this is a mesh from all the probes that we have in Thailand. You see that we have 27 probes in Thailand. So this is a mesh between the network in Thailand. And if it's light green, it means that it doesn't go through IXP. But the good thing in this picture is that the path remains within a country. This is an example of Indonesia. In Indonesia, we have around 99 probes, many more probes. But if you look at on top of the row in cell light brown, it means that the path is going outside the country and it's not going through IXP. So maybe this can be interesting. You can see, despite that it's going outside the country, it's not going far because it's just going through Singapore. But this one of the things that you can use with RIS Atlas, despite of the fact that this is a prototype tool, you can use this already. And if we have more probes within Thailand, we will be able to see more of what's going on, whether a path between networks go outside the country. If you're a network operator, you will be interested in this visualization, because this visualization is what we call word latency map. The data is coming from all the measurement that we have from RIS Atlas and where the probes that we have. It's showing, this is the view. So how does RIS Atlas network sees your network? In this case, it's through online 17552. So I want to make sure, I want to see all the networks that sees that are within 50 milliseconds, and anything above that, make it red, so that I can have a bit of idea where this AS is. So as you can see in the picture, it's around Thailand. And if you look closer and zoom in, we will have another angle of what we see. So now it's showing something from the probe's point of view. So which network are there in the neighborhood of this probe? So in this picture, you can play with the button. If you push it, if you click to the left, it will go all the way to the lower latency, and then you can click to the right, it will go all the way to the higher latency. And in this case, and then you can check whether this network that are listed here with the latency that shows on the board, are there supposed to be there? If it's if the latency is high, for example, in this case, I try to find one network within Thailand. I can only find Thai gateway, and the latency is quite good. It's 58 milliseconds, so it's not a problem. So this is not, well, this is an example, but you know, quite, yeah, it's okay example, because it could be worse, right? It could be that one network within a country, and then the latency is like maybe more than 200 milliseconds, for example. So you can try it yourself. This is where you can try it. Like I said, it's a prototype tool. We would like you to try it and give us feedback. Would you like to see something else? Would you like, what kind of data would you like to see? What kind of visualization? How can we make it better? Is it even useful? If you tell us, then we will be able to determine later, okay, many people use this tool, let's make it into production. But without this feedback, it will probably remain a prototype forever. All right, let me give you some more reason to love RIP Atlas. So we have global coverage, more than 12,000 vantage points around the world at your disposal. Feel free to use them. And then it's from trusted source, because RIP NCC is a not-for-profit organization, and the probes that and the volunteers that host these probes, they're mostly in end-user network. Of course, they're also in data center or in offices, but mainly in end-user network. It's safe and secure because we do regular security review, and we share the result of the review with the community. And then it's open data. I already mentioned that the measurement result is open to all. It's community driven by RIP NCC and by the community for the community. And you know, this is the best thing. You don't have to break your bank in order to use RIP Atlas. You just need to create an account. And I think if you, the first time you create an account, you will get a bit of credit to play with. So if you host a probe, you will get credits on a daily basis. So it's a take and give. Okay, let me say it's the best internet measurement platform in the world. All right, what's next? I mentioned already, create an access account and install probes in strategic location. I'm sure you know where you want to put the probes, what network are important to you. And if you are a network in Thailand and you are one of the network listed as a peer RIS, to peer with RIS, and start testing. Use the platform. It's there for you to use. Monitor your network, and if you have disconnected probes, kindly reconnect it. This is a voucher that you can use of 500,000 credits. I think with this voucher, it's enough to give you to play around and run ongoing measurement for a while. So now we get into the software probes. As I mentioned already, we have the software probes in production. It's exactly the same, except that it's a software. So the software package that works just like regular probes. And we have CentOS 7 and 8 in source and also in binary. This is the one that we support from the RIP NCC. So if you install this software in your network, it will be much faster. It takes like maybe five minutes to install this software probe. But we also have the Raspbian, Docker, Debian, OpenWRT. This is supported by the community. The code, the script is available as well, and there's also videos to show you that it's not complicated to install the probes. I can say that because I'm not very technical, and I can install it in Raspberry Pi. So some people said, oh, it's quite complicated, but in fact, if you follow the video, the manual and the video, it's quite straightforward. Okay, so now I'm going to show you, it's a short demo, it's around 5 minutes, just to give you an idea of that it's possible to install the probes. I have it here. Oh, the sound can't be. Can we connect the sound? So there, when I installed this software probe in my Raspberry Pi, it was one of the things that I was a bit stuck. It was when I need to copy the file from the.
Right. So moving on,
yeah.
I will be talking about binary. Right. So moving on, I will be talking about binary installation, binary package installation in CentOS 7 or CentOS 8. Moving on to the CentOS binary installation, let me go back to the terminal and let me switch to the other terminal tab which I have inside here, which is basically running CentOS 7.8. But having said that, the instructions are pretty much the same. The only difference is probably the package path as well as the package names. So let me go ahead and do that. So the first thing what you need to do in the case of CentOS 7 or CentOS 8 is to download the packages, and you can download the packages using a command line tool like curl. So once you do that, if I do a listing, you see that the package is downloaded. But having said that, this is actually not the RIP Atlas software package. This is only the package for the repository information. So as I said, in Linux and Unix world, you have package managers. So this package manager will talk to repository servers. So this package is basically installing the repository server information inside your Red Hat or more specifically CentOS 7 operating system. So what we will do is, the next thing what we will do is we can also verify that the file hasn't been tampered with. And the way we can do that is to check the checksum of it. I'm sorry, the file name must have changed. Let me see. Right, so you can use the SHA-256 sum to check the checksum value. So in case of any tampering, and this is something that is, this checksum or hash value is present on the RIP Atlas website. So you can verify that the file hasn't been tampered with, or the file in downloading, there hasn't been any kind of issue with regards to a corrupt download, say for example. Then the next thing what we will do is we will install the package which we have downloaded. And the way to do that is by using the package manager command yum. So yum install, let me choose the correct one. You need to be root. So in this case, I need to prefix the command with sudo. And when I do that, it will ask me whether I want to install it. And I say yes. And just to give you a behind the scenes understanding of what exactly happened. So this package basically installed a file in the directory /etc/yum.repos.d, and there would be a file called as RIP-atlas.repo. So this package is just installing the repository information about it. It's not actually installing the probe. So the next thing what we will do is, now that the repository information is known to my operating system, I will use the command yum install atlas sw probe. That's the name of the package. This is the one which is going to install the probe. So we will go ahead and install this package. And once you do that, then the step remains the same, which we did for the Debian operating system, which was to copy the SSH public key. And once the public key is given to the RIP Atlas system, then it will generate or create the probe in their infrastructure. Let me be ready for a while.
Yeah, so that's more or less the steps.
So it is asking me whether I want to install this package. I say yes. It will also install this package as well as other dependencies like ps-misc as well as net-tools. And once it is installed, we print the SSH public key on screen and then put it in the system. So here is the same command which we did for compiling and installing the probe on Debian operating system. So here is the SSH public key. I put it here. I say accept and I say submit. And what that will do is it will send a request to the RIP Atlas infrastructure. So I get an email saying that the probe is I believe the first one was sent 9 minutes ago, maybe another 5 to 6 minutes, we should receive it. So by the time we do Q&A, we should have received an email saying that the probes have been.
Yeah, so it takes about 15 minutes before your application is confirmed. So you first get a confirmation that we receive your application, and then another 15 minutes to that you can activate your probes. So as you can see, all the script is available on GitHub. What I did was I just copy and paste it, and it was quite straightforward. And now let me go back to my presentation. I'm at the end of my presentation. I'm just going to give a short demo with the new UI. So okay, so this is the new RIP Atlas dashboard. Let me just go there. So now we have everything on one page on the RIP Atlas dashboard. It depends on, you can choose if you are a probe host, how to determine the cards, what your preference are. If you are an ambassador, you can also choose the one that is suitable to you. So in this case, let's say you are a probe host, you have information about welcome on board and about the credits, about my probes. And this is just a start guide. All the information that you need is there. And then if you go down, the new thing is the quick look measurement. So this is kind of handy if you would like to show what RIP Atlas platform can do. You can just go here, and if you know what the target, if you want to, it will show the last quick measurement that I did. This was, I tried to measure apnic.net on the 27th of May using a traceroute measurement, and then you just click, it will pick random probes to run this measurement, and then if you click on the measurement, you will see this. This was the measurement that I created. This is the result, and this is the new UI. So it's slightly different than what I show you in the with the use case. You can adjust you can sort it, and it will show you this kind of information. And this is the details of the measurement. So this is nice. The quick look is a good, easy example if you want to explain RIP Atlas to your colleague, for example. And then if you go back to the dashboard, you will have information about your credit. You can move the cards to the place that you prefer. So it's very interactive in a way. And then you have this measurement, and then you can go and check the measurement, for example. But what I would like to show you is actually, okay, let me go to the measurement page. If you go to the measurement page, you will have all the measurement that people have created here. And then you have the public measurement that people have created, and then you have your measurement, which is my measurement. I would like to show you this new measurement page. Let me see. This was the one that I created. This was a trace route to bangkokpost.com, and it's an ongoing measurement. So I keep on getting result every 30 minutes, if I'm not mistaken. So from all the probes within Thailand, and they are in different networks. And you can see here that the latency is pretty good within Thailand. But if you want, you can adjust it. And there's only one hop. Can you imagine? How great is that? And then you can see the information, for example, because there's only one hop, it's not very interesting. But what you can do now with this measurement, you can manage this. For example, if this is an ongoing measurement and some of the probes that you use are no longer connected, you might want to take those probes out, right? So what you can do, you can remove probe, for example. You can click here and choose the probes that you want to remove, and then click remove probes. These probes will be removed. Or if you don't want to, if you want to stop the measurement, it's very easy now. It used to be hidden, now it's very easy. You can just click stop measurement. It will ask you again about, are you sure you want to stop this measurement? So, and then you can also add probes now. Choose from the probes that you want to have, of course, and then you can reuse the existing measurement, but this has to be your own measurement. So actually, I'm at the end of my presentation. I'm not going to use extra time because this is the end of it. If you have any question, you can say it now, or you can talk to me after the presentation. And thank you for the time. No question?
Anybody have question?
Should we approach you as a community and have only one account and many probes, or should each organization register for their own account?
So both ways is possible. It would, because we have a RIS Atlas ambassador in Thailand. We have Nan, who has been helping us deploying probes within Thailand. So what we can do is we can arrange it with Nan if it can be arranged collectively through RIS Atlas ambassador. Of course, you can always apply directly to RIS NCC, but when you apply directly, it takes a longer time because sometimes it's stuck at custom. But if it's going through the ambassador, normally we ship a package in registered and express. So there's normally less issues logistically. Yes, thank you.
Thank you, Lia. For the next session, please welcome Philip Smith for Routeviews and BGP data updates.
So you get a lovely view of the coast of Queensland just beside Brisbane, which is not very useful when you want to see the presentation. Let's try this instead. Full screen. So I'm going to present from the PDF because the PowerPoint is just very, very slow. I don't know what Microsoft are doing these days. I really Anyway, so I'll just use the PDF, which should be a bit zippier. Yeah, it was hard to know quite what to present about this because Lia was talking about, you know, the RIS project, the RIPE NCC has been running as well as all the Atlas. And so, you know, I usually have spent a lot of time whining about the internet routing table. And I thought it would also be useful to talk a little bit about Routeviews as well. And I presented last year at Beacon X Peering Forum about Routeviews, and Tashi talked a little bit about it yesterday at the Peering Forum. But I thought I would just give a little bit more, not about, well, what Routeviews the thing is, but just, you know, some of the things it could be used for and just some of the work that we've been doing. But before we do that, I thought, well, we'll have a bit of a look at the global routing table. Those of you who have been at the workshop for the 4 days that Tashi and Jose and I taught will probably know what we've been whining about in some of the workshop, because that was all about best practices, how to run the routing system securely, and so forth. So this is just a little bit more context, I hope. Okay, so the Internet Routing Table. There are a lot of tools available out there for actually looking and seeing what's going on. You know, I was talking with Mike Gartner just before we started about, you know, some of the ancient, well, not ancient, but certainly the last century data, like in the 90s. For those of us who were there in that period, we didn't really think about looking at the routing table because, well, you know, it was just the internet, and, you know, we were playing with it because it wasn't really being used that seriously. So none of us really recorded BGP tables. And I mean, Routeviews started collecting data in 1995. Dave Meyer set up, what was it? I think it was a Cisco AGS. Might have started with a Cisco AGS at the University of Oregon. He worked at the network services there. And I was like, yeah, I'll just get a BGP feed and people can log into it and have a look-see. And, you know, we sent them a feed from the UK. We logged into the Routeviews node and we did try PBGP, and it was, woo, there are prefixes. And so the tool evolved really as somewhere you could log into and do trace routes and find out what happened to your routing. And then we started getting more the concept of other operators doing this. They set up things called looking glasses and so forth. And then Routeviews, you know, Dave, as he went around ThaiNOG and RIPE meetings and came other parts of the world, got more BGP feeds from other operators. So the Routeviews project became actually quite useful. And it was 1997 that the data started being archived. V6 data was much more recent. I need to check back through the MRT archive to see when V6 was started. I think it might have been like 2010 or thereabouts. But certainly V4 has been recorded since 97. Lia talked about RIS, so I don't need to talk anything about that. It's a complementary project. RIS collectors are in different parts of the world from where Routeviews has collectors. So using the two facilities, operators have got a really very good view of what's happening. Tony Bates started the CIDR report when he was at the RIPE NCC, and that was all about moving from class A, B, C over to classless routing and trying to encourage operators who had got blocks of class Cs /24s in modern money to try and aggregate those into bigger pieces, because the routing table was going super exponential in '94, really before we had the full deployment of classless. I started doing routing table analysis work in 1998, really when I moved from Europe to this region, because it was kind of, well, you look at the CIDR report and it had the top 20 providers, but most of those were North American or European. Being on the CIDR report is not a good thing. It's a bad thing because it shows how badly you're running your BGP. You're massively deaggregating. So I was kind of curious what was happening in this part of the world, so I started doing the similar idea. I was pretty much running the CIDR report anyway by then, but leaving the original thing, trying to do my own just to see what's happening in this part of the world. So I split it all up into registry regions, and I could break it down per country and so forth. So I got BGP feed from APNIC. They had appointed president in Japan, of course in Brisbane. They had one more recently in Hong Kong. I got from Bhutan Telecom. So basically links Equinix Singapore. And of course I used the original Routeviews router, but then Dave stopped the show IP BGP on the, by then it was what, a Cisco 7200 VXR of some description. Actually no, the first one was a Cisco 4700. So not the AGS, 4700 then became the 7200 VXR. It kind of, you did a show IP BGP on that and you could go away, make a cup of tea or coffee and come back and it might have started displaying something. So, there's certainly been lots of places you can grab BGP tables from. And so I started doing that, started recording V6 in 2010. That was a bit of a mistake. I should have started much earlier. And it was only people who had been asking me for a few years, Philip, when are you going to do V6? I'll get around to it. And yeah, well, I should have started. Much to my regret, I should have started much sooner than that. So I now have got to go back, try and find all the data from other places and see if I can do the same, backfill some of the report. So let's look at it. 30th of May, that was yesterday. This is what the global table looked like, in my view. About 953,000 V4 prefixes. One thing I do is I work out aggregation, and if every AS aggregated perfectly, the global table would be 360,000 prefixes. So you can throw away 600,000 prefixes of the global BGP table today, and you will lose no reachability. So 2/3 of the global table is junk. That's pretty bad. So your router, if you've got full BGP today, 2/3 of the memory used to store the table is junk. Are you happy about it? Obviously you are, because you're happily carrying it. Are the vendors happy? Delighted, because they can sell really expensive routers with big fast fibs and big fast memory, because you're very bad at running your networks. Anyway, so there's the summary. This is a daily email that goes out to various lists. Let's look at the APNIC region. So about 255,000 prefixes from APNIC region ASs. So those are autonomous systems that are, well, delegated by APNIC or in APNIC database as being from this part of the world. If operators here did aggregation, it would drop to 74,000. So it's even worse than the global situation of the amount of junk that's flying around in the routing table here. Anything else exciting here? No. Well, I could talk all day on one page, but anyway, let's look at the global. Let's look at the global junk. So these are the world's worst operators. I don't mean from quality of service, I mean from behavior in the global BGP table. So number one worst is this Mexican Uninet, who are announcing 12,200 prefixes. If they did some aggregation, BGP command like filters and aggregates, they could bring it down to 489. I think the marketing department must run the company, not the, maybe they don't have any network engineers. Certainly looks like it. You trundle on through the list. So everything in blue is this part of the world. So, China Mobile, 9,844. If they did aggregation, it would come down to 69. That's a lot of mess. TPG in Australia, a lot of mess. CERNet, a lot of mess. FPT Vietnam, well, the folks who've been to the workshop know this because they saw pretty much the same thing. VTEL, Bharti Airtel, Telekom Indonesia, and VNPT. But you can see some really spectacular ones. VTEL, 3,900 prefixes announced, aggregation 21. That's a massive, massive waste of just being announced to the global routing system. Anyway, what about V6? Just in case you think V6 is wonderful and perfect, it is not. We're almost 200,000 prefixes in V6. What else is interesting? Almost 200,000. Total autonomous systems, about 32 compared with 77,000 in V4. Yeah, will do for now. I haven't worked out aggregation yet for V6. Project for a rainy day, at least when I get a bit of spare time. I'll try and start work on that. So looking at the biggest providers for V6, the Mexicans love to be #1. I think they're doing everything they can to stay ahead of Amazon, who's #2. So I don't know, but look at all the blue there. Again, with the large prefix announcements in V6. I haven't looked at the aggregation as in done anything automated, but most of those, it's massive deaggregation. It's not they've got huge amount of prefixes. They're announcing lots and lots and lots and lots of 48s for reasons I cannot figure out at all. You can look at the paths, they're identical for every single announcement. So looking at the prefix sizes, so yesterday, 22, 23, 24 are the big things that are being announced. 24s onwards and upwards. This time last year, we've jumped about 25,000/24s. It's about the only growth area in the V4 routing table now. In fact, the V4 routing table is hardly growing at all. So /24s. If you think V6 is better, likewise it is not. The major growth area in V6, well, the registries hand out /32s to network operators. It's only end sites that get 48s. So the registries do make some end site assignments, but by and large, the registries hand out 32 or bigger. But look at the 48s. In 1 year, we've jumped almost 8,000/48s. That's not the registries handing out 48s, not at all. That's operators going, ooh, I've got a 32. Let me chop it up into little pieces. How many 48s in a /32? Quite a few, like 65,000. So if somebody takes a 32 and chops it up into 48s, only your router vendor is going to be happy because they can sell you a multi-million-dollar router just to carry the billion prefixes that will end up in the BGP table. So the V4 routing table growth, you notice, okay, the scale's not very useful, but in the last years, probably since the start of the pandemic, so 2020, the growth has actually slowed down. You can see that. It's kind of starting to tail off. The V6 table, the growth has gone from exponential, starting to tail off, but it's still growing. Right? It's still growing quite noticeably. The V4 AS growth, that's very noticeable tail off. Very noticeable. Again, 2020, it all just started slowing down like that. You know, from this point here, going over further to your right. Whereas V6, it hasn't, you know, it's carried on almost a straight line. This step here is quite exciting. This step here was APNIC handed out 4,096 ASs and 4,096/32s to a big research network in China who promptly announced them all. So that's why we have a 4,096 AS jump. So, I mean, they withdrew it, and then they re-announced it, and then withdrew it, and re-announced it, but it's been there ever since. So it's kind of interesting to see that big step in the V6 table. The V4 aggregation, well, the blue line is the global table. The red line is if operators would actually aggregate. The green line, what happens there is people have taken their aggregates, divided them, and then left holes. It's like, why are they even doing that? So they've got address space that they're simply not announcing. And we all know what happens to unannounced address space. Other people will borrow it for bad things. So why this is even real, I simply don't know. It just seems bizarre. If you've got address space, announce it. If you don't have it, get rid of it. Other people will want it. V4 prefix sizes, what are the growth areas? 22s kind of stalled, 23s have stalled, 24s are not on this. So I was tracking this because these have all been different minimum allocation sizes by the registries over the years. I think I'll stop showing this one because there's no growth here. It's kind of boring. because V4s run out everywhere, pretty much. And the only growth area now in the V4 table are /24. So I don't know. Maybe another year I'll show this, then I'll give up, because there's not much point. /24s, the red line, onwards and upwards. I mean, the V4 table will become all /24s within the next few years. That's pretty obvious. So just as address space is chopped and you know, moved around, it's very clear that the V4 internet, it's market forces that are driving the routing, well, the address space now. The whole custodian thing that we had with registries looking after the address space, if you don't need it, you give it back to the registry, long gone. It's a total market now. V6, well, I think whatever, you know, we always talk in networking terms when you're designing, building a network, whatever you do in V4, you do in V6. Unfortunately, operators have done the same thing for the routing announcements. Whatever brokenness you do in BGP for V4, they just repeat the brokenness in V6. So we get the /48s heading upwards. The 32s, which is tracking the registry allocations to operators, it's steady growth, nothing really exciting, but the 48's going crazy. The V4 address space announced. Look at that. See what happened? So that big step, that was the US DoD announcing, how many /8s did they have? 4 or 5 /8s? Well, they always had them, but now they're announcing them just because, well, they have them and they don't want other people to use them, I suppose. But look at the line after that. It's actually going down. So the V4 address space that we see in the global internet is now starting to drop. Not quite sure why or what that means, but it's starting to drop, the total address out there. AS announcements, well, I showed that earlier, starting to tail off. You know, the green is the N-site AS, so the multi-homed N-site organizations, that's tailing off. The yellow one is ASs that are also providing transit, tailing off as well, and the transit-only ASs hardly ever moves. So transit-only means they don't originate any address space. They're only in the transit path. So it's tailing off. V6 AS announcements, most autonomous systems are origin only. There are very few ASs that only do transit. There's like about 10. It's about 10 or 11. So it's almost a pointless graph to show as well. One of my fun ones, maximum AS path length on the global internet. So, you know, here's some interesting ones. I mean, I told the class how these are caused. There's a certain certain cheap equipment vendor who has a slightly different syntax from the mainstream vendors about how you do AS path prepans. Right? The maximum AS path length you can do is obviously the field is 256 autonomous systems. And people who are used to coming from Cisco and all the others, when they configure on this particular vendor, they type in the AS number rather than the number of prepans. And of course, you take the number, you divide by 256, and the remainder times 256 becomes your prepand. So we see this. And in early years, it used to be a big problem because the software vendors never checked if the AS path was bigger than 256. And when it was, it started overwriting other memory in the router, and the router would crash or worse. Is there worse than crashing? Well, yes, it's corrupting the announcements and so forth. But that's what it's been since 1999. You know, it's kind of interesting that in the early internet, we were all very well behaved and nice. And then really when it came to about, this would be about 2007, 2008, it all went bad. What happened in 2008? Don't remember. Right, global financial crisis, 2008. So, prepans. Looking at deaggregation, that's one of the things I do. So I've got global and per RIR report is, no, it's on the APNIX website. APNIX supported me for years doing this. I've started doing it for the R&E networks now because the US National Science Foundation is really curious what the R&E networks are doing globally. Turns out they're not doing any better than the commercials. And you'd think that R&E, being the forefront of anything new, would be showing good example to the commercial internet. It's not the case, not the case at all. So deaggregation, yeah. So I work out the deaggregation factor, which is take the global table, aggregate it as much as you can, and then that's the difference. So globally, it's about 2.6. When I started doing this, it was about 2.1. So North America, so the AREN region, 2.21, Europe, 2.1, that's what you would expect. Because everybody needs to multi-home, need to do traffic engineering, need to leak sub-prefixes, which are chunks of address space to do traffic engineering. So North America, Europe tend to do the right thing. The rest of the world, they do traffic engineering by leaking /24s or /48s. That's not traffic engineering in anybody's book, right? It's not traffic engineering. You cannot traffic engineering with the smallest bit of prefix that you have. If you've got a /16, what does traffic engineering with a /24 do on average? Not much. Right? /24 is a 256th of a /16. It's just nonsense. But people, they're not doing engineering at all. They're just using a hammer, bang, bang, bang on the keyboard in the hope that something good happens. So, it looks like this. Africa region, Latin America region. Latin America is improving. And it's improving because there are more exchange points, more interconnects in Latin America. Miami is no longer the interconnect for Latin America. The big successful exchanges, especially Brazil and neighboring countries, that are making quite a bit of difference to some of these interconnects. But, Asia Pacific region, it's been kind of bumbling along at 3.5 for probably 10, 12 years now. Things aren't improving, even though we're adding lots of exchanges. So exchange point is not a solution to the deaggregation, even though it's often claimed to be the solution. What else? Okay, now the fun part. The aggregation savings possible in the Asia-Pacific region. Well, I pointed them out already. So the biggest saving possible, these are the top 20 of the biggest savings possible. China Mobile, number 1, announcing 9,844. If they did aggregation, we could save 9,775. So they're contributing 9,775 prefixes of junk to the BGP table. Followed hotly on the heels by TPG in Australia, followed closely by China Education Research Network, FPT, VTEL, Telecom Indonesia, Bharti Airtel, VNPT, Airtel, Tencent, Tata, BSNL, TOT, hello TOT, nice to see you. Korea Telecom, Bharti, China Mobile, SIFI, and Pakistan Telecom. It's mostly China and India don't know how to do BGP. TOT also need to learn. Please come to my workshop. It's apparently quite good. Thailand. So, number of networks, 1,948 TOT. If you did BGP and did a little bit of aggregation, you could save the internet, 1,932. What are you doing? You're obviously not using BGP. Please fix it. True, hello True. I helped set up your network many, many years ago when you were starting. What happened? Why did you ignore everything I taught you? Please fix this. CAT, same thing. Right, we go through the list. CSL. CSL still exists? Anyway, CSL, you're there. Still appears as the S number. Anyway, there's the list. There's your homework. When I come back, hopefully, maybe, possibly, maybe I can never come to Thailand again, but if Beaconix invite me back, hopefully I can see great improvements on this list. Anyway, I thought I'd share it because people were asking me, what does Thailand look like? It must be quite good. Not really. Okay, Routeviews. What is Routeviews? I thought I'd put up the background of what it is. So, collaborative looking glass. It's a big community project, all run by volunteer project. been running since 1995. Archive started 1997. It's about 50 terabytes of BZ2 compressed data. That's quite a lot. So University of Oregon is where it is. NSRC is now the custodian of the project. We took that over, 2 years ago when the previous custodian left University of Oregon to join, join the commercial world, let us say. So a lot of people support Routeviews all around the world. Where the collectors are, so this is a map of the world using a different projector. I think it's almost up to date, not quite, but it's pretty close to being up to date where we have collectors. Of course, there's one here in Thailand at BGP. The Singapore one, we just upgraded from using ancient Quagga to free-range routing just, on my flight here, I was in the lounge in Singapore, and Matt Jensen very kindly went in and swapped the box around for us while I was sitting in the lounge. So that's good. So the collectors are there. We're always looking for more, not just any old place. We're looking for interesting locations that have interesting peers. So probably a lot in North America. We'd like to get more, and we are working on more in this part of the world. But we have to just work through the process. We're not in a big rush because we're trying to supplement other places. But could have a few more in Africa, a few more in the Middle East. We just got a new one in Iraq, in Baghdad, just about a month ago, supported by DKIX. So that's going to be quite interesting. And we've got a few in Southeast Asia happening as well. So there they are. Locations, internet exchange points is where they are, or data centers that have internet exchange points or big interconnects. And what we want to try and do is peer with the participants of the exchange points. So peer with either bilateral peering with the exchange point member and or peering with the exchange point route server. So I've been doing quite a bit of work the last few months just to tidy up a lot of these peerings that have been set up over the while. We also can accept multi-hop. These collectors are at the University of Oregon, so we can do multi-hop to folks who are not present at the locations we are at. So all the data is collected as MRT. So we take BGP dump every 2 hours, full BGP table in each collector. It's stored as MRT. We take updates. Updates are collected all the time using MRT, and the update file is dumped every 15 minutes. So the idea is eventually to be able to see the live data, what's happening. So we're working that. So it's a facility a bit like RIS has, where you can see the live changes. We're not quite there yet, but we want to supplement what RIS is able to do right now. So that's been worked on. As I say, MRT files are bzipped and then are synced back to the archive there. The idea event is, and we're working on, so the developer's working at the moment, is to have a BMP feed instead. That's a much more scalable way. But at the moment, we want to make sure the BGP feeder is actually scalable. And that's happening at the moment. And that feed will be from the collectors, not from the peers. So that's what we're trying to get done. So coming soon, definitely by the end of this year. So here's the BGP one. We're using free-range routing, FRR. The collector sits there. It's on the exchange point. Thank you very much to BGP for providing the VM to run our collector on and host this. It's been running since 2019, so for the last 5 years. I'm sure it's been running longer than that, but it's only 5 years. So there we are. So you can get the data from it. So what Routeviews can do, you've got command line access. I really want to limit the command line access as much as we can. So I've piloted a looking glass front end, which will be the main way of doing the telnet style access to the looking glass. You get prefix visibility, usual blah, blah, blah. The blah, blah, blah means you can log into a router somewhere and do things. You can do trace routes and look at the BGP table for your prefix and so forth. That's really the goal of what we're trying to do. And with the archive, looking at historical BGP data. So, you know, folks like Kentic and so on can look at a lot of that historical data. You know, Doug Midori's done some great presentations on, ooh, look what happened 5 years ago, and trace things through. Again, using the historical data, same way that RIS has historical data as well. So that's the looking glass. I'm piloting. I need to find somebody who, well, I have somebody who can code to make this work a bit better. And what we'll do is we'll withdraw Telnet access. Telnet was meant for humans to be able to log in and do show IP BGP. What a lot of people have done is they've written scripts that Telnet into all 45 collectors every few seconds and do show BGP. That just kills the collector completely. So we now rate limit Telnet access. And if people are doing silly things, we ban them totally, because it's meant to be there for casual troubleshooting, not for downloading full BGP tables. So the collector will look, sorry, the looking glass will look something like this. You select the command you're going to run with the prefix you want to run it against or the option, and it's much tidier that way. BMP, as I mentioned, that's happening. RPKI, we now have all the collectors talking to two validators. We use stay router and routinator. FRR has preferences for them. It doesn't load balance between the two. So stay router, RPKI client is our validator of choice, and routinator is the backup. So you can check your ROAs on any of the collectors worldwide. This is Routeviews 2. It's one of the multi-hop collectors. So this is after the tidy up. You may have seen all the presentations with the mess. Now I've tidied it all up. So it's 32, mostly full BGP feeds. So you can see the typical routing table that we're getting from many of the entities. And you know, there's a lot of historical, well, still historical tidy up needed there with some of the company names that have not been touched since, well, 20 years ago. So we need to tidy that up still. But it gives you an idea of what you can see. Please do not do show IP BGP on this collector. You can go away and have dinner before you'll get any answer. And you'll likely get your IP address banned as well. So here's the BeaconX one. Thank you, Nan, for helping me tidy it up the other day. So show BGP summary is here. So the 13 peers now. So we added in peering with the route server, so it's about 110,000 prefixes what we see. So now we can see the Thai internet, at least as it is peering with at BeaconX, which is actually very good. It makes troubleshooting. So BeaconX members trying to figure out connectivity issues can just jump on this collector and try and work out what is or isn't working with the routing. So you know, we've got a few. Amazon don't actually peer with the route server, so we have them separately there. What's this one showing? Oh, this is the V6 one. So the BeaconX V6 LAN is transitioning from one /64 to another one. So I've kind of edited this a little bit. So some peers have moved to the new, and other peers are still stubbornly using the old LAN. So we'll be moving soon. So those four at the top will be hopefully moving. Well, what's the deadline? Next week, I think, to move. So operations, fun things. So those who were at the workshop, remember I was whining about AS37447? Well, there it is. What are they doing? Well, it's still the best path. So I've no idea why they need to do a 97 times prepend. It looks pretty, but that's the current longest AS path in the global internet. You know, if you feel bored, you could write to these people and say, hey, why are you doing 97 times prepend? I've tried. I can't be bothered. You know, they don't reply. Or they do, what you're talking about. No idea. Here's another one. Right, you can check the invalid rows. So again, you know, I just picked the top of the table. You know, here we've got this /24, the row is invalid, it's originated by 9583. I have no idea who actually should be originating it. And then there's another one that you can display the invalids, very easy, just jumping onto one of the collectors. What else? Yeah, this one. Anybody from AS13150 here? Can you come to my workshop next year, please? You're at an exchange point. When you're at an exchange point, you announce all your prefixes. You don't announce just one. And then you announce all your other prefixes to your transit providers, who then announce them to the exchange point. What are you doing? This doesn't make sense. If you're an exchange point, announce all what you have. Because at the moment, your peers, well, you're paying money to access people you could peer with. I don't know, maybe you've got too much money. Can I have some of it? So this is one example, but that's what I mean by strange cases. You can jump onto a collector and see how your routing's working. If you've broken something by accident or your automation is broken, you could have ended up something like this. Why pay Hurricane Electric Transit to get access to your network? I don't get that. Anyway, I could spend hours just giving examples from the collector. So we're looking for new views. I mean, I've got about 5 or 6 offered in the whole of the region, which is good. It's just needing resource and wheels to turn and so forth to get these happening. So we'll see. We've got DKIG's JHB now, which is kind of handy for that part. Of course, we've got Singapore, BeaconX, we've got BDIX. Philippines we have, and GOREX we have, and, well, yes, GOREX we have. With one and wide, which we need to update, but, we're working on a few more. So hopefully we can get, well, India we definitely need, Korea, Japan. Yeah, Korea is there. What's missing on the map? New Zealand we need. New Zealand is on the map. Anybody from New Zealand who's watching? Because a lot of these maps seem to drop New Zealand. India, of course. We'll see. Impact, well, Jeff uses it for what he does, so that's what he said. FTAB uses it, well, the Manos Observatory, when ISOC still thought Manos was important, rather than handing it off to somebody else. But, FTAB, same story. Manos Observatory makes quite a use of all the route views data, as well as, of course, the RIS data that Lia was talking about. And visualization, this is quite something. So Barrett put all this together, and it's like the history of the Internet Routing Table. I forget how many years. It's like something like 20 years. It's a really impressive animation. Please don't run it on the hotel network. It's slow enough as it is without you trying to run that. But when you go home, run it on your home broadband. It's worth watching. It's quite impressive. You may have remembered Kado years ago doing the big picture of the internet and trying to do an animation. Computers are much modern, they're faster, they've got the GPUs, and you end up with, this is just a snapshot. I can't even read it, but I think it was a snapshot from probably about, no, I don't think, oh, that is the time, 2023, that's where that picture is. So anyway, the slides will go on the website. So I know some of you asking where you can download. They'll go on the website soon, I hope. So now has the PDF, so it'll go up, and you can have a look at, well, go play that URL. If you want to peer with route views directly, I mean, at BeaconX, I only get the Thai routes. But if you want to bilateral peer with the route views node at BeaconX, let me know. I'd love to get the full routing table, because then it shows us what your view of the full routing table is. And as you saw from the route views 2 image, every operator has a completely different view of what the full table looks like. So you want to do that. If you're not a BeaconX member and you're in Thailand, well, you can either go to BeaconX or send an eBGP multi-hop feed to us at the University of Oregon. That's it. Any questions? There are no questions. Excellent, I can go. Are you going to tidy up your internet, Thai ISPs? Yes, good, I had a yes. That's all I need.
Thank you, Philip, for interesting information. And now we will take a break. เดี๋ยวเราจะเบรกกัน15 นาทีนะครับกลับมาอีกทีตอน16 นาฬิกานะครับหรือว่า4 โมงเย็นนะครับเพื่อจบเซสชั่นสุดท้ายของเราในวันนี้นะครับ